Today we are going to have marathon run. We have to solve lot of problems. Uh, so I will conduct today's class in slightly different track on different mode than as usual. I want now Madhura to unmute herself. Madhura,
Yes, sir.
do you have calculator?
Yes, sir.
Okay. So let us go ahead with this problem solving session. Keep yourself unmuted. In yesterday's class, we were discussing this problem. I will read it out. Uh, a 2,100 pound tractor is used to lift 900 pound of gravel. Determine the reaction at each of the two A rear wheels and B front wheels. So we were discussing all this is the all that is which is I have marked in blue color is the thought process. This is not the step in solving the problem. This is a thought process. So we wrote down all the equilibrium equations. We identified trivial equilibrium equations which are not useful in solving for unknowns in this problem. So even though they are satisfied, those are useless equations. So we scrapped all those equations, and meaningful equations are only two: summation Fy equal to 0 and summation moment about Z equal to 0. Then we discussed something called as free body diagram. So what do we mean by free body diagram? Free the body from all external agencies and show what the external agencies were doing. इसको हमने define किया free body diagram. So now for this tractor, we also have drawn free body diagram. For this tractor, if I free the tractor from external agency called as earth, we have to show what the earth was doing. So earth must be applying upward force reaction and upward force reaction at A and B. So those are shown as RA and RB. And the weight of the tractor, that is the gravitational pull exerted by earth on the tractor, is shown at his center of gravity, and that is 2100 lb. So and then we have shown all the distances with reference to a chosen reference point. तो इसको हमने बोला था free body diagram. We freed the body from all external agencies and we showed what the external agencies are doing. Now somebody may argue, why did I show RA and RB upward? I have shown it intuitively. You may choose to show it downward, no issues. Later on, you will get a negative sign after analysis. So negative sign will then indicate originally assumed sense of RA is incorrect. Are you with me, Madhura?
Yes, sir.
Okay. Now we have also defined a coordinate system X, Y and Z coming out of the plane of paper towards you. ऐसे डिफाइन किया है. Now in practice means while solving the problem with pen and paper, you cannot draw the sketch. ये ट्रैक्टर आप ड्रॉ नहीं कर सकते. So then you can draw the line diagram. So जरा देखो यहाँ पे किसी भी ऑब्जेक्ट का y distance दिया है कहीं भी. Madhura, tell me, is the y distance given here anywhere? That means where this CG located with reference to the ground, ये वाला distance दिया है क्या problem में?
No, sir.
Are you with me? So therefore I can safely idealize this body as 1D body. तो मैंने 1D assume किया है, and then I have shown just a line to represent this tractor. Are you with me?
Yes, sir.
Then this is RA, this is RB and 210. Somebody was in last class confused about RA and RB is inclusive of 2100 lb and whatnot. But we have to understand that we have to show all the external forces. What is the magnitude of RA and what is the magnitude of RB? That we will decide based on the equations of equilibrium. Are you with me?
Yes, sir.
Okay, and all these dimensions, all these lengths are given in inches. Now we have three equations with us. We have 2 points. This is point A. This is center of gravity, so I will call that point as G, and this is point B, and let me call this point as C. So this is free body diagram. Now I want to determine RA and RB. There are two unknowns. We have already found out which are the two equations that we are using. We are going to use summation Fy equal to 0 and summation of moments about Z equal to 0. Do you agree with me?
Yes, sir.
And now let us say I use summation Fy equal to 0 equation. मुझे क्या equation मिलेगा? जरा दिमाग में लिखो ये equation. क्या होगा? Plus RA minus 2100 plus RB minus 900 equal to 0. Do you agree with me?
Yes, sir.
But this equation involves both the unknowns RA and RB. So this equation in itself cannot give me the value of any of the unknowns. Do you agree with me?
Yes, sir.
Therefore, while we know that there are two equations and two unknowns, it is always better to choose the equation to be used first wisely. पहले कौन सा इक्वेशन हम यूज करने वाले हो थोड़ा सोच के यूज करना. दैट सिंप्लीफाइज द प्रॉब्लम टू अ लार्जर एक्सटेंट. कैसे? अब जरा देखो, आई हैव टू टेक समेशन ऑफ मोमेंट्स of all the forces about z axis. Natural question that I am going to ask is z axis passing through which point? Are you with me, Madhura?
Yes, sir.
So I can take point A, I can take point G, I can take point B, I can take point C, and I can take summation of moments of all the forces pass about z axis passing through any of these points on or off the body. You can consider a point at the other corner of the universe, and for the same problem you can apply equation summation of moments about z axis passing through that point equal to 0. कर सकते हो mathematically.
Yes.
Are you with me?
Yes,
But
sir.
there are advantages if we choose particular points. For example, if I choose to take summation of moments of all the forces about z axis passing through A, what is the moment of RA? Batao.
0.
Because RA has its line of action passing through A, so therefore it is not going to cause any moment. So the only unknown that would generate moment about z axis passing through A will be RB. Do you agree with me?
Yes, sir.
And then I will get the value of RB straight away. Are you with me?
Yes, sir.
So I can choose either RA, I can choose either moment about A, or I can choose moment about z axis passing through B. If I choose moment of all forces about z axis passing through point B, RB का moment 0 रहने वाला है. The only unknown involved will be RA. Are you with me? So these, out of these two choices, you can choose any one. So let us begin with. So I am going to choose first moment equation intelligently because I want to straight away get the value of one of the unknowns. Are you with me? If
Yes,
we use
sir.
summation Fy, that is not possible. So therefore, the first equation that I choose is summation of moments about z axis passing through A. अब इन सबको हम शॉर्ट हैंड में बोल देते हैं समेशन ऑफ मोमेंट अबाउट ए. आर यू विथ मी?
Yes, sir.
आपको समझना है, इट इज अबाउट z axis. This must be equal to 0 is the first equation that I'm going to employ or that I'm going to use. So can you tell me what is the moment of 2100 LB about A?
Minus 2100 into 20.
Very good. Because it is clockwise. 2100 into 20. Now, what is the moment of RB about A?
Plus RB into 60.
Plus RB into 60. Why plus? Because we have assumed RB to be upwards, and therefore it is going to cause anti-clockwise moment about A. If after the analysis RB turns out to be negative, its sign will be automatically taken care of, because when I say RB equal to minus value, then it automatically becomes minus and the moment becomes clockwise. Are you with me?
Yes, sir.
So there is no bar on what direction of RB and RA you assume. जो भी डायरेक्शन एज्यूम किया है उसके हिसाब से साइन दो. आर यू विथ मी?
Yes, sir.
नाउ what और किसका मोमेंट आने वाला है? we are going to also have the moment of this 900 LB, and what will be that moment? Tell me.
It will be negative of 900 into 110.
900 into 110. Very good. What is 110? 110 is the perpendicular distance between point A and line of action of AB. That means it is this horizontal distance. That turns out to be 20 plus 40, 60 plus 50, 110. Happy?
Yes, sir.
If you equate this to 0, now solve this and tell me what is the value of RB.
It will be 2350.
Great. So RB has turned out to be 2350 pounds. Are you with me?
Yes, sir.
Mind you, this pound is the unit of mass, but it's okay. We can multiply it by gravitational acceleration and we can get it in terms of force. It's all right. So RB is equal to 2350 pounds. And as it has turned out to be positive, तो उसका मतलब क्या है? उसका मतलब ये नहीं है कि it is upward or it is in positive y direction. No. Its meaning is originally assumed sense of RB is correct. Are you with
Yes,
me?
sir.
हाँ, तो
Yes,
क्या
sir.
मतलब है इस पॉजिटिव साइन का? देखो, देयर आर टू साइन कन्वेंशन साइमल्टेनियसली गोइंग ऑन. व्हेन आई राइट डाउन दिस इक्वेशन ऑफ मोमेंट्स, क्लॉकवाइज एंटी क्लॉकवाइज इज द साइन कन्वेंशन. डू यू एग्री विथ मी?
Yes, sir.
When I write down the equation for summation Fy equal to 0, forces in positive y direction treated positive, forces in negative y direction treated negative is the sign convention. Are you with me?
Yes, sir.
But when I interpret the sign of unknown, what it means is, if the sign is positive, originally assumed sense of RB is correct.
Yes, sir.
इसका मतलब ये नहीं है कि वो पॉजिटिव y या नेगेटिव y डायरेक्शन में. इट हैज नथिंग टू डू विद दैट. Positive sign here indicates that originally assumed sense of RB is correct. Therefore, I will state that here for the first problem. Originally assumed sense or direction of RB is correct. Are you with me?
Yes, sir.
This is the interpretation. And therefore, originally assumed sense was upward, therefore it is upward. मिल गया?
Yes, sir.
So this is the one of the answers. हमें दो reactions निकालने के लिए बोला गया है. तो the answer to the part B is RB is equal to 2350 pounds upward.
Yes,
Are you
sir.
with me? Now, how do you find out RA now? Now to find out RA, I can use summation Fy equal to 0. Do you agree with me?
Yes, sir.
And how does that go? RA, that RA plus RA, because it is in positive y direction. This is the sign convention now for applying the equation. RA minus 2100. Do you agree with me?
Yes, sir.
Plus RB, because I assumed RB to be upward and it has turned out to be upward. Therefore, that plus sign will be retained and it will be 2350. Are you with me?
Yes, sir.
And minus 900 equal to 0. So tell me.
650
So RA has turned out to be plus
plus
650 pounds. So what is the meaning of plus sign? Originally assumed sense of RB is correct. And originally assumed sense of RB is upward. Therefore, it is upward. Are you with me?
Yes, sir.
Now, can you do one thing for me? What is the sum of RA and RB? 3000.
Yes, sir.
And what is the sum of external load? 900
900 plus
plus
again 3000.
3000. So therefore, RA plus RB total reaction has to be equal to the total forces applied by the tractor on the ground. Do you agree
Yes,
with
sir.
me? So this completes the solution of first problem. अब जरा इसमें किसी को कुछ डाउट है तो अनम्यूट करके डायरेक्टली डाउट पूछो, नहीं तो we will go to the next problem. Madhura, you keep yourself unmuted.
Yes, sir.
You have tremendous job today. We are going to discuss and solve all the problems. किसी को डाउट है तो पूछो फर्स्ट प्रॉब्लम में. Okay. Now before we go to the second problem, let me ask you, what type of force system is this? So when I ask you the question, what type of force system is it, you have to look at the free body diagram. तो अब इस free body diagram में मुझे बताओ, are all the forces lying in single plane? Are
Yes,
there
sir.
lines of actions lying in single plane? So observation number 1, lines of actions, LOAs of all forces in single plane. कौन सा plane है वो? XY plane है. Do you agree with me?
Yes, sir.
Then tell me, are there lines of actions intersecting in one point? No.
No.
समझ में आ रहा है? So LOAs of all the forces do not intersect in a single point. Do not intersect in single point. Are all lines of actions parallel to each other?
Yes.
So all LOAs, lines of actions of all forces, are parallel to each other. Are you with me?
Yes, sir.
तो ऐसे फोर्स सिस्टम को क्या कहा जाता है? तो इमेजिन दैट इफ लाइंस ऑफ एक्शंस ऑफ ऑल द फोर्सेस वुड हैव बीन पासिंग थ्रू ए सिंगल पॉइंट, तो हम उसको कंकरेंट बोलते. आर यू विथ मी?
Yes, sir.
कंकरेंट का मतलब क्या है? लाइंस ऑफ एक्शंस और ऑल द लाइंस दे मीट इन सिंगल पॉइंट, तो कंकरेंट बोलेंगे. बट ये कंकरेंट नहीं है. सो दिस इज कोप्लेनर. कोप्लेनर क्यों? बिकॉज लाइंस ऑफ एक्शंस ऑफ ऑल द फोर्सेस डू लाई इन सिंगल प्लेन. सो ये कौन सा सिस्टम है? कोप्लेनर. आर यू विथ मी?
Yes, sir.
बट नॉन कंकरेंट. कोप्लेनर है, नॉन कंकरेंट है,
Yes.
लेकिन पैरेलल है. बिकॉज लाइंस ऑफ एक्शंस आर लाइंस ऑफ एक्शंस ऑफ ऑल फोर्सेस आर पैरेलल टू ईच अदर. आर यू विथ मी?
Yes, sir.
सो कोप्लेनर, नॉन कंकरेंट बट पैरेलल फोर्स सिस्टम. देखो, आपको ये भी देखना है कि आपने अगर सिलेबस देखा तो उसमें ये पॉइंट थ्योरी का पॉइंट करके मेंशन किया है. एंड ऑल द बुक्स आल्सो गिव द थियोरेटिकल डिस्क्रिप्शन फर्स्ट एंड देन दे सॉल्व द प्रॉब्लम. We are taking the another way. We are solving the problem first and then we are trying to configure it as various force system. So अगर ये problem हमने solve किया है तो we have understood what is coplanar, non-concurrent, parallel force system. Are you with me?
Yes, sir.
And what are the equations of equilibrium that are relevant for such kind of force system? ये हमें समझना है. Are you with me?
Yes, sir.
So don't say that we have not covered that in theory. There is another way of looking at it. We could have covered the theory first and then solve the problem. But I believe that once you solve the problem, these concepts do fit in your mind. Are you with me?
Yes, sir.
So ये कौन सा problem है? Coplanar, non-concurrent, parallel force system. How did you decide the type of force system? By looking at free body diagram. So you have to look at free body diagram and decide the type of force system and then proceed. Are you with me?
Yes, sir.
Chalo. So immediately in the next problem, you will understand the difference. Chalo. So Madhura, can you read this problem?
A collar A is connected as shown to a 50 lb load and can slide on a frictionless horizontal rod. Determine the magnitude of the force P required to maintain the equilibrium of collar when X is equal to 4.5 inches and B X is equal to 15 inches.
Yes. So frictionless rod है. इसका मतलब क्या है? That means, yeah, go ahead. Somebody had doubt. Okay. So frictionless rod है. उसका मतलब क्या है? When I slide the column along this bar, I am not going to have any frictional resistance. Are you with me?
Yes.
So when I slide this collar A with force P, I am not going to have frictional resistance offered by the rod. The rod cannot offer frictional resistance. Are you with me?
Yes.
So what kind of reaction the rod can offer? The rod can offer only normal force. It cannot offer frictional resistance. Am I very clear about
Yes,
this? Okay. So what is said? Collar A is connected as shown to a 50-pound load through pulley. And this pulley also is frictionless. उसका मीनिंग क्या है वो भी हम जरा समझेंगे. But you have to understand that this pulley also is frictionless. That means as this string runs over the pulley, there is no friction between the pulley and string. Are you with me?
Yes, sir.
और पूछा क्या है आपको? Determine the magnitude of force P required to maintain the equilibrium of the collar. Do you agree with me?
Yes, sir.
तो अब मुझे बताओ, इस प्रॉब्लम में हम फ्री बॉडी डायग्राम किसका बनाएंगे?
The weight, 50 lb weight.
And what does that going to give us? इक्विलिब्रियम किसका देखना है बताओ?
Of the collar.
हाँ, so isn't it very clear that you have to draw the free body diagram of collar?
Yeah.
Are you with me?
Yes, sir.
हाँ, so जरा देखना प्रॉब्लम में सिर्फ इक्विलिब्रियम के कंसेप्ट आपको पता है नहीं चलेगा. You have to also understand what is being asked in the problem. उसके हिसाब से उस बॉडी का फ्री बॉडी डायग्राम बनाना है. Are you with me? I have
Yes.
so many choices. I can draw the free body diagram of pulley at B. I can draw the free body diagram of this weight C. I can draw the free body diagram of this rod. I can draw the free body diagram of rod plus collar. There are so many choices. But you have to look at the narrative of the problem. You have to see what is being asked and accordingly decide कि कौन से body का free body diagram बनाना है. That is the first point that I want to make. Are you with me?
Yes, sir.
So as we are talking about the P required to maintain equilibrium of a collar, this phrasing makes it absolutely clear that I have to draw the free body diagram of collar. Are you with me?
Yes, sir.
चलो. So what all is external to the collar? वो बताओ. Is earth external to the collar?
Pardon?
Is earth external to the collar?
Yes, sir.
Yes. So I am just now listing down all the external agencies for the column. First thing is earth. Second, is the rod external to the column?
Yes, sir.
Collar. Yes, rod is external to the collar. So I am going to write it as rod. Then, is cable external to the column?
Yes, sir.
Yes. So therefore, cable ही बोला है ना, collar A is connected as shown. So cable you can call it as string or cable. I will call it as cable. That is also external. Are you with me?
Yes, sir.
This 50 lb weight, is it external to the column? External
Yes,
to the
sir.
collar. But is it directly connected to the collar? No. It is connected through cable. Do you agree with me?
Yes, sir.
So 50 lb का जो वेट है उसका इफेक्ट कॉलर तक पहुंचाने का काम केबल कर रहा है और उस केबल को मैंने ऑलरेडी एक्सटर्नल एजेंसीज में लिखा है. देन आई एम नॉट गोइंग टू राइट डाउन दिस 50 lb वेट नाउ. आर यू विथ मी?
Yes, sir.
Are these supports external to the column? Yes, they are external, but this support supports the pulley supports the string which is attached to the column. So column के लिए जो जो चीजें external है, सिर्फ कॉलर के लिए जो जो चीजें एक्सटर्नल है, सिर्फ वही चीजें मैं यहाँ पे लिखने वाला हूँ. आर यू विथ मी?
Yes, sir.
कॉलर को कनेक्टेड. नाउ, इज फोर्स P external to the collar?
Yes, sir.
Yes, and that P must be applied by some body. So I am going to add one more thing in this list. Body which applies force P. Do you agree with me?
Yes, sir.
हाँ. देखो, अब तक हमने दो चीजें सीखी है. प्रॉब्लम को कैसे सॉल्व करना है वो स्टेप वाइज सीखना, ये तो आपका काम है ही, लेकिन उसके साथ साथ क्रिटिकल थिंकिंग भी डेवलप होना चाहिए, थॉट प्रोसेस भी डेवलप होना चाहिए. सो जस्ट लुक एट द वे वी आर अप्रोचिंग द सॉल्यूशन फॉर अप्रोचिंग द प्रॉब्लम. कैसे किया? सबसे पहले तो हमने ये सोचा, डिसाइड किया कि किसका फ्री बॉडी डायग्राम बनाना है. आर यू विथ मी?
Yes, sir.
Then we listed down all the external agencies as far as the body for which the free body diagram is to be drawn. उसके लिए कौन कौन से external agencies है वो सारा यहाँ पे लिख लिया. Are you with me?
Yes, sir.
अब ये जो प्रोसेस हमने यहाँ पे लिख के किया है, ये प्रोसेस आपके दिमाग में चलने वाला है while solving the problem. So it would not consume more than 5 seconds. Are you with me?
Yes, sir.
चलो. So now let us write down. Let us draw the free body diagram of collar. So FBD of collar. You can as well write it as only FBD. But if you write it as FBD of collar, that gives the sense of maturity to the examiner. Not to the examiner, even for yourself. किसका FBD draw करने वाले है वो लिखना चाहिए. So free body diagram of the collar that I am drawing now. चलो. एक एक चीज. अब earth is external. So if I free the body from earth, I have to show what the earth must have been doing on the collar. Do you agree with me?
Yes, sir.
So earth must be pulling the collar by its own weight. मतलब
Yes.
earth must be applying a gravitational pull on this collar corresponding to its mass. Do you agree with me?
Yes, sir.
But is the mass mentioned anywhere? कॉलर का मास कहीं भी दिया है नहीं. सो इन अ वे इन द प्रॉब्लम इटसेल्फ यू हैव बीन गाइडेड टू निग्लेक्ट द सेल्फ वेट ऑफ कॉलर. आर यू विथ मी?
Yes, sir.
तो उसके एंगल्स देखो इस प्रॉब्लम में, एंड विच इज ट्रू if you compare the force P, if you compare the tension in the string that you will calculate after the solution, you will see that the self weight of this collar is very negligible in comparison with all those. So it can be fairly neglected. Are you with me?
Yes, sir.
But still, I am going to show this self weight as this is the first problem, or as it is one of the introductory problems. तो ये किसका है? Self weight of the collar. I will call it as WC. Do you agree with me?
Yes, sir.
Weight of the collar. That is the action taken by Earth on the collar. What is the action taken by rod on the collar?
It's
The rod
frictionless, so
the rod cannot apply any force in this direction. It is not possible. Do you agree with me?
yes,
The rod can apply only normal force, and normal to the rod is vertical here. Are you with me?
yes, sir.
So therefore, what is the action taken by rod on the collar, or what is the reaction provided by rod on the column? It is going to be a force like this. Do you agree with me?
Yes, sir.
As it is the reaction offered by the rod, I am going to call it as RR. Happy?
Yes, sir.
Okay. Now, what else? Third body is cable. Cable is also external to this rod. Agreed?
Yes, sir.
अब मुझे बताओ, what kind of force that cable can sustain? Can it have compression? Take a string, try applying compression to it. Is it possible that the string will be able to resist that compression? No, it will just give way. Do you agree with me?
Yes, sir.
So इस string में कौन सा force होना चाहिए? Tension होना चाहिए. Agreed?
Yes, sir.
Okay. So इस string में tension होना चाहिए, ये तो समझ में आया. And what is the angle made by the string with reference to horizontal? ये angle कितना है? क्या आप ये बता सकते हो? This theta will be equal to tan inverse of
20 by x
20
by
by
x.
x. Happy?
Yes, sir.
हाँ, तो अब ये तो सॉल्यूशन का पार्ट है. तो इसके आगे का स्टेप कौन सा रहने वाला है? फाइंडिंग आउट दिस थीटा tan इनवर्स ऑफ 20 by x. अब जरा देखो, पार्ट ए ऑफ द प्रॉब्लम में x कितना दिया है? 4.5, और पार्ट बी ऑफ द प्रॉब्लम में x कितना दिया है? 15 इंच. आर यू विथ मी?
Yes,
तो
sir.
कैन आई फाइंड आउट थीटा फॉर पार्ट ए? पार्ट ए के लिए थीटा कितना होगा? tan इनवर्स ऑफ 20 by 4.5.
Yes, sir.
हाँ, so tell me how much is that? Tan inverse of 20 by
4.44.
4.5. कितना?
Tan inverse of 4.44.
Yeah, you tell me the angle
Okay.
in degree.
Uh, 0.077.
That is in radians. Please change your calculator to degree mode. .31 degree, is it right?
Yes, sir.
Yes, sir.
So it is 77.32 because it is 319. So it is 77.32 degree. Are you with me?
Yes, sir.
And for case number 2, that is problem case number B, what will be? What it will be? So it is going to be 53.13 degree. Am I right?
Yes, sir.
कर रहे हो ना? मेरे ऊपर भरोसा मत करो, मेरी हिस्ट्री है. आई मेक कैलकुलेशन एरर्स, सो यू हैव टू डू इट. 53.13 डिग्री. आर यू विथ मी?
Yes, sir.
ओके. सो दोनों प्रॉब्लम के लिए हमने ये थीटा तो कैलकुलेट कर लिया. And now we have to draw the free body diagram. I am going to draw free body diagram in such a way that it is common for both part A and part B. So I am not going to mention theta here. I am simply going to write it as theta. When it is part A, theta is equal to 77.32 degree. When it is part B, theta equal to 53.13 degree. Are you with me?
Yes, sir.
Now, I'm going to put on the video for a second. Just a minute. Okay. Are you able to see me?
Yes, sir.
Now, just look at my hands and tell me whether I'm applying tension or compression on this object. Can you tell me that? Madhura?
Yes, sir. You're applying tension.
No, I am applying compression. How will you be able to tell that? Do you understand my point?
Yeah.
So, just looking at my hands, you are not looking at my expressions. You will not be able to tell me whether I'm applying tension or compression on this object. Happy?
Yes, sir.
Now tell me, when will you be able to tell me whether it is tension or compression? क्या करना पड़ेगा? So microscopically you will have to observe the deformation. Do you agree with me?
Yes, sir.
If it is elongation, I was applying tension. If it is contraction, I was applying compression. सही है?
Yes, sir.
But if I don't have to observe the elongation or contraction, is there a way in which I can know whether I was applying a compression or tension? If I give a cut in between, if my hands go apart, I was applying tension. If there is a tendency of two parts to overlay, then I was applying a compression. Do you agree with me?
Yes, sir.
So whenever you cut the object, the internal forces get revealed. Happy?
Yes, sir.
तो अब जरा देखो, I want to show on this free body diagram the force exerted by the cable on the collar. Do you agree with me?
Yes, sir.
तो उसके लिए क्या करना पड़ेगा? I need to give a cut. Happy?
Yes, sir.
So I have given this cut now, and I am going to show that tension, therefore, in this fashion, which makes an angle of theta with horizontal. Happy?
Yes, sir.
चलो, और क्या बाकी है now? The body which applies the force is also external. So if I free the object from that body, I have to show what that body was doing. So it was applying force P. So I need to show this force P as well.
Yes.
Do you agree with me?
Yes, sir.
अच्छा, तो अब जरा देखो इसमें unknowns क्या क्या है? Is theta known? Whether it is part A or part B, theta is known.
Yes. Yes, sir.
Is this weight of collar known? No, it was not given in the problem. Do you agree with me?
Yes, sir.
Whether this normal reaction offered by the rod on the collar is known? No, not. We have not found out it. It is unknown. Are you with me? And question
Yes,
is T known? Is T known?
Yes, sir. It's 50 L.
How? How do you know the value of T? So अब ये ध्यान में रखना, अभी हमने पुली का चैप्टर किया है, but as long as the pulley is frictionless, whatever is the tension on one side, same remains the tension on the other side. ये हमेशा ध्यान में रखना. Are you with me?
Yes, sir.
As long as the pulley is frictionless, if on one side of the pulley the string has the tension of T, on another side the string has tension T as well. ये समझा. Now question is, what is the tension in this string is to be answered. Do you agree with me?
Yes, sir.
हाँ, तो वो इंट्यूटिवली तो समझ में आया 50 LB, बट व्हाट इज द बेसिस? तो बेसिस ये है, देखो, आई एम गोइंग टू नाउ गिव ए कट हियर एंड आई एम गोइंग टू ड्रॉ फ्री बॉडी डायग्राम ऑफ ओनली दिस मच पार्ट ऑफ दिस स्ट्रिंग. ये क्विकली, ये दिमाग में करना है. कैसे करना है? देखो, उतने ही पार्ट का स्ट्रिंग मैंने दिखाया. इज द रिमेनिंग पार्ट ऑफ द स्ट्रिंग एक्सटर्नल टू दिस पार्ट? डू यू एग्री विथ मी?
Yes, sir.
Yes.
Yes, sir.
So therefore that part pulls this part by amount T. That's what is being shown. Because this part is going to pull the upper part by amount T downwards by Newton's third law, the upper part must be pulling this part up by amount T. Do you agree with me?
Yes, sir.
And then this 50 lb weight is also external, so I am going to show that. And I have to show the self-weight of this string as well, but self-weight of this string is negligible, so that is not shown. So this is 50 lb. Are you with me?
Yes, sir.
This is the free body diagram of only this much part of the string. Happy?
Yes, sir.
And now, as this system is in equilibrium, as this system is not moving in y direction, therefore I can apply Newton's second law, which manifests itself as the equilibrium equation, summation Fy equal to 0, and then I get plus T minus 50 equal to 0. Do you agree with me?
Yes, sir.
And then I get T equal to 50. ये जो प्रोसेस हमने अभी किया, ये आपके दिमाग में चल रहा है, ये लिखने की जरूरत नहीं है. Are you with me?
Yes, sir.
So therefore, as this T is 50, this T is also 50. Are you with me?
Yes, sir.
As the pulley is frictionless, I argued that this T and this T are same, and therefore this is 50 lb. Happy?
Yes, sir.
चलो, अब मुझे बताओ, ये जो सिस्टम आपका फोर्स का तैयार हुआ है, ये सिस्टम को किस तरीके का फोर्स सिस्टम है? What kind of system it is? So tell me, are the all lines of actions of all the forces? यही क्वेश्चन हम खुद को पूछेंगे, ये 3 क्वेश्चन. Are lines of actions of all the forces lying in same plane or not?
Yes, sir.
Yes. So LOAs, lines of actions of all the forces, they are lying in same plane. Are you with me?
Yes, sir.
I am talking to Madhura as a representative of the class. तो किसी को भी बीच में कोई भी डाउट हो, you can unmute yourself, you can stop me right there and you can ask the questions. Don't keep anything pending. वहीं पे पूछ लो डाउट. So lines of actions in same plane. Are you with me, Madhura?
Yes, sir.
Okay. Now, what about, are these lines of actions meeting in the same point?
Yes, sir. They are.
Yes, because shape and size of the collar is also not given. So we assume that the collar is a particle, and all the lines of actions of forces, they do meet in a single point. Are you with me?
Yes, sir.
अगर इस कॉलर के डायमेंशंस दिए होते तो चीज अलग थी. Then we will have to decide whether they are meeting or not. But as the dimensions are not given, we have to assume that all these forces, their lines of actions do pass through a single point. So second point देखो कौन सा है? LOAs of all forces meet in a single point. Are you with me?
Yes, sir.
Yes. किसकी बात चल रही है? सिर्फ कॉलर की. कॉलर के ऊपर जो सारे फोर्सेस है वो एक लाइन में मीट हो रहे हैं, ऐसे बोल रहा हूं. Don't misunderstand me. Are you with me? So we are looking at this FBD and we are talking the description of only this FBD. Nothing else, not anything else. Are you with me?
Yes, sir.
Okay. चलो अब आगे चलते हैं. Are the lines of actions parallel? No way. They are not parallel to each other. Do you agree?
Yes, sir. Yes, sir.
तो इस तरीके के फोर्स सिस्टम को क्या बोला जाता है? देखो, इस तरीके के फोर्स सिस्टम को बोला जाता है कोप्लेनर and concurrent force system. Are you with me?
Yes, sir.
Concurrent. तो अब जरा मुझे बताओ, concurrent force system अगर है तो बॉडी क्या है? एक पॉइंट है. So if I take the summation of moments of all the forces about any axis passing through this point, is it going to be 0 always?
Yes, sir.
कौन से भी एक्सिस, x हो, y हो या z एक्सिस हो. Let me define the axis. So let us say this is x, this is y, and coming out of the plane of both towards you is z. Are you with me? कौन सा भी एक्सेस इस पॉइंट में से पास होने वाला, सब जगह सारे फोर्सेस का मोमेंट 0 ही होगा, क्योंकि सारे फोर्सेस की लाइन ऑफ एक्शन तो उसी पॉइंट में से पास हो रही है.
Yes, sir.
Are you with me? Therefore, whenever we are talking about concurrent force system, the notion of moment is trivial. Though moment equilibrium equations are satisfied, those are trivial identities. For example, summation of moment of all the forces about x axis passing through a point is 0. तो 0 equal to 0 आएगा. सारे forces एक ही point में से जा रहे हैं तो 0 ही है. Summation of moment of all the forces. Do you agree with me?
Yes, sir.
So summation of moments of all the forces about x, y, and z axis, these three equations, they become redundant equations or trivial equations. They are satisfied, but they are useless because they do not involve any unknowns. Do you agree with me?
Yes, sir.
तो therefore कोप्लेनर और कंकरेंट फोर्स सिस्टम के लिए मायने रखने वाले इक्वेशंस कौन से हैं? तो समेशन एफ एक्स इक्वल टू 0, समेशन एफ वाई इक्वल टू 0 एंड समेशन एफ जेड इक्वल टू 0. आर यू विथ मी?
Yes, sir.
Are you understanding the difference between earlier problem and this one? This was
Yes, sir.
coplanar but non-concurrent force system. Equation written in terms of moment had meaning. That meaning is lost here. Are you with me?
Yes, sir.
हाँ, तो अब हमारे पास कितने इक्वेशंस है? समेशन एफ एक्स इक्वल टू 0, मीनिंगफुल इक्वेशंस. समेशन एफ वाई इक्वल टू 0. अच्छा, समेशन एफ जेड इक्वल टू 0 इस केस में मीनिंगफुल है क्या?
No, sir.
नहीं, because there is nothing in z direction as it is coplanar force system. Therefore, for coplanar and concurrent force system, we have only two independent equilibrium equations, summation fx equal to 0 and summation fy equal to 0. दो ऑर्थोगोनल डायरेक्शंस उस प्लेन में लाए होने वाले चूज करो. उसके अबाउट समेशन ऑफ फोर्सेस इज 0 आर द ओनली टू मीनिंगफुल इक्वेशंस. आर यू विथ मी? फॉर कोप्लेनर एंड कंकरेंट फोर्स सिस्टम.
Yes, sir.
हाँ, तो कंकरेंट है इसलिए मोमेंट के इक्वेशंस नहीं, कोप्लेनर है इसलिए फोर्स में से भी सिर्फ दो इक्वेशंस. तो ज्यादा से ज्यादा कितने अननोन सॉल्व कर पाएंगे हम इस प्रॉब्लम में? बताओ.
Two.
Only two unknowns we can solve for. And how many unknowns are there?
3.
No, this weight need not be taken as unknown, though it is not given here. It can be measured. So if weight is known, can I find out remaining two unknowns like P and RR? Do you
Yes,
agree with
sir.
me? Yes.
Yes.
But यहाँ पे जरा देखो, समेशन एफ वाई इक्वल टू 0, ये इक्वेशन यूज करने में कोई इंटेलिजेंस नहीं है, बिकॉज वी आर नॉट बीन आस्क्ड एनीथिंग अबाउट RR. डू यू एग्री विथ मी?
Yes, sir.
हमें पूछा क्या है? सिर्फ P फाइंड आउट करो. अगर सिर्फ
Yes.
P फाइंड आउट करना है तो समेशन एफ वाई इक्वल टू 0 ये यूज करना पड़ेगा ही नहीं इक्वेशन. डू यू एग्री विथ मी?
Yes, sir.
So not required. This equation is really not required. So we are not going to use this equation and we are going to use summation fx. देखो प्रॉब्लम का सॉल्यूशन 30 सेकंड का है. ड्रॉ एफबीडी, राइट डाउन समेशन fx इक्वल टू 0, डन. बट आई एम ट्राइंग टू डेवलप थॉट प्रोसेस. अगर कोई कॉम्प्लेक्स प्रॉब्लम आ जाए तो उसमें आपको क्या क्या चीजें ध्यान में रखनी है ये सीखो इस सॉल्यूशन से, ना कि ये प्रॉब्लम के स्टेप्स. आर यू विथ मी?
Yes, sir.
ओके. सो समेशन इक्वल टू समेशन एफ एक्स इक्वल टू 0 ये इक्वेशन में अब अप्लाई करने वाला हूं. सो 50 cos थीटा, देखो, एंड टुवर्ड्स राइट, सो इट इज पॉजिटिव. डू यू एग्री विथ मी?
Yes, sir.
50 cos theta and minus P. This must be equal to 0. Do you agree with me?
Yes, sir.
So therefore P must be equal to what? P must be equal to 50 cos theta. Happy?
Yes, sir.
Chalo. So tell me the value of P now for case A. For case A, theta is equal to कितना है theta? 77.32 degree. Are you with me?
Yes, sir.
So tell me how much is P?
10.975.
10.9
975
यूनिट बोलो. पाउंड.
pounds.
यूनिट के बिना कोई मतलब नहीं. आर यू विथ मी?
Yes, sir.
समझ में आ रहा है कि नहीं? यूनिट के बिना
Yes.
उसको कुछ मतलब नहीं ना. जैसे सिर्फ पोस्ट ग्रेजुएशन को कुछ मतलब नहीं, कौन से स्ट्रीम में इंपॉर्टेंट है, इंजीनियरिंग कर रहे हो, मेडिकल में हो, किस में हो, वो वैसे ही यूनिट के बिना पी को कोई मतलब नहीं. नाउ देन नेक्स्ट पी, व्हाट इज द वैल्यू ऑफ थीटा हियर? इन सेकंड केस थीटा इज 53.13 degree. Are you with me?
Yes, sir.
So now tell me what is the value of P in second case?
30
equilibrium.
pounds.
Pardon?
30 pounds.
हाँ, चलो. अब based on this solution, if we stop here, इट्स ऑल राइट, क्योंकि सॉल्यूशन तो हो गया, बट इफ वी स्टॉप हियर वी आर गोइंग टू लूज द इनसाइट. सो इसके बाद भी एनालिसिस करना है, सॉल्यूशन क्या एनालिसिस करना है. सो लेट मी आस्क यू फ्यू क्वेश्चंस. चलो, व्हाट इफ इन केस ए द वैल्यू ऑफ पी इज 9 पाउंड, तो क्या होगा?
The collar will move towards the right.
Right, yes, that means weight will come down. Are you with me?
Yes, sir. Yes.
What if the value of P is 12 pound in first case?
The weight will go up,
Weight will go up, collar will move towards left.
move towards left.
Only at this particular value of P, the equilibrium is going to be maintained. That means no one is moving, no one. ये situation सिर्फ इस केस में होगा. Are you with me? For this value of P. Happy?
Yes, sir.
अच्छा, अब जरा मुझे एक चीज बताओ. As theta reduces, do you observe that P is increasing? देखो, थीटा जैसे रिड्यूस हो रहा है वैसे P इंक्रीज हो रहा है. Do you agree with me?
Yes, sir.
Are you with me?
Yes, sir.
So now can you tell me for what theta P will be maximum?
Theta is equal to 0.
Right, theta equal to 0, cos theta is equal to 1. That means you are going, this string is going to apply force like this. So this pulley is going to be somewhere here. Are you with me?
Yes, sir.
ऐसे जब होता तो उस केस में ये पूरा का पूरा फोर्स P को रेजिस्ट करना पड़ता. Do you agree with me?
Yes, sir.
And that time P will be maximum. How much will it be? 50.
50.
So we understand that P is going to be less than 50. ये
Yes,
तो
sir.
समझा. अब when P will be minimum, P कुछ लगेगा ही नहीं इक्विलिब्रियम के लिए. ऐसे कब होगा?
When theta will be equal to 90 degree.
Right, that means the pulley is something like this.
Yes.
Are you with me?
Yes, sir.
At that time, this tension is not trying to slide the pulley, it is trying to push it up. So therefore P is not required for equilibrium. Do you agree with
Yes.
me?
Yes, sir.
And for any value of theta between 0 to 90, P will lie from 50 to 0.
Yes.
समझ में आ रहा है? थीटा जैसे जैसे बढ़ता जाएगा वैसे वैसे P की वैल्यू कम होती जाएगी, क्योंकि हॉरिजॉन्टल कंपोनेंट भी स्ट्रिंग के टेंशन का कम होते जाएगा. हैप्पी?
Yes, sir.
So with this insight, now let us try to guess the solution for next problem. Next problem क्या है जरा देखो. Same problem. Slide. Determine the distance x for which the collar is at equilibrium when P is equal to 48 lb. P already दिया है 48 lb. Are you with me?
Yes, sir.
P 48 lb means, is it very very close to 50 lb? Do you agree with me?
Yes.
So therefore this distance x in fact is going to be very large in comparison with these two distances. Do you agree with me? तो ही
Yes.
थीटा 0 के पास जाएगा. Are you with me?
Yes, sir.
हाँ, तो हमें समझ में आया कि थीटा अभी x डिस्टेंस क्या होने वाला है. x डिस्टेंस इज गोइंग टू बी वेरी लार्ज इन कंपैरिजन विद 4.5 इंच एंड 15 इंच. वो कितना है वही पूछा है. So are we going to do anything different than this? No. Free body diagram, all these steps are to be borrowed as it is. समझ में आ रहा है?
Yes, sir.
All these steps are to be borrowed as it is. And what is the relationship? Relationship is P is equal to 50 cos theta. है ना?
Yes, sir.
P is equal to 50 cos theta. तो इसमें अब P दिया है हमें. P कितना दिया है? 48. Are you with me?
Yes, sir.
It's 50. So tell me how much is cos theta? How much is theta? Tell me how much is cos theta?
0.96.
0.96. But by definition, what is cos theta? बताओ.
It is the horizontal component.
हाँ. So अब एक काम करते हैं. This is x, right?
Yes, sir.
Are you with me? So what is cos theta? Cos theta is adjacent side upon hypotenuse. Do you agree with me?
Yes, sir.
So ये अगर theta है तो what is the adjacent side? Adjacent side itself is x.
X.
And what is a hypotenuse? Square root of x square plus 20 square.
Yes, sir.
So square root of x square plus 20 square. हो गया. Now solve this and tell me the value of x. कितना आ रहा है? नहीं इतना टाइम नहीं ले सकते आप. Tell me, is it 68.57? मैं आपके साथ ही सॉल्व करना शुरू किया हूं. That means what it means is you are not using calculator correctly. चलो, somebody confirm. मधुरा,
Yes, sir. Just a minute.
कैसे सॉल्व कर रहे हो बताओ आप. स्क्वेयरिंग करके वगैरह वो सब नहीं करना है. You have to write down this equation directly on the calculator and use shift solve. चलो आशुतोष, have you solved it? आशुतोष, can you unmute yourself?
Solving, sir.
इतना टाइम क्यों लग रहा है? आशुतोष,
Yes, sir.
why are you taking so much time? How are you solving? Tell me. अरे आप बताओगे तो I will be able to help. चैतन्य, unmute yourself. Chaitanya,
Yes, sir.
yes. Have you solved this?
No, I'm still doing, sir. Just a minute.
How are you solving?
Sir, by taking the root term to the left side and squaring.
No. You don't have to do all that. You have to type this equation as it is on calculator.
Okay. Sir, I don't have a scientific calculator.
Okay. So make sure that you have it from next lecture. Deep,
Yes, sir.
have you solved?
I'm trying, sir.
Okay. So Madhura, do one thing. Substitute this 68.58 here and tell me whether you get 0.96 or not. If you get it, I have. Then we will go ahead. Madhura.
Okay, sir.
Yeah.
Sir, I got 68.57. It's correct.
Sir, yes, sir, I got 68.57.
Great. So therefore, the answer is x is equal to 68.57 inches, and as we discussed, it is greater than 4.5 or 15 inch. That was expected. Are you with me?
Yes.
Okay. So now let us solve the next problem, and then we will stop. So we have 5 minutes. We may venture 5 minutes into your recess. Pardon me for that, but we will finish this set today. A seller is being rescued using boatswain's chair that is suspended from a pulley that can roll freely on the support cable ABC. So बहुत ज्यादा कुछ imagine नहीं करना है, यहाँ पे दिया है. So this cable CD will be pulled so that this pulley moves here, and then this entire assembly with seller that goes towards left. तो इस तरीके का assembly है. Now freely बोला है, इसका मतलब है the pulley is frictionless. Freely का मतलब क्या होता है? Frictionless. Roll freely मतलब frictionless. Are you with me, Madhura?
Yes, sir.
This is frictionless. On support cable ABC, and it is pulled at the constant speed by cable CD. It is pulled at the constant speed by cable CD. इसका मतलब क्या है? That means acceleration is 0. Are you with me?
Yes, sir.
And still I can use equations of equilibrium. Happy?
Yes, sir.
देखो कितना मतलब you have to read between the lines. If it is not pulled at a constant acceleration, then I cannot use equation of equilibrium in x direction. But as it is pulled by the constant speed by cable CD, मतलब ये जो पुली C है, इसका इस direction में speed constant है, velocity is constant, so I can use equations of equilibrium in x direction. Are you with me?
Yes, sir.
That's what it is being said. Knowing that alpha is equal to 30 degree and beta is equal to 10 degree, and knowing that the combined weight of chair and seller is 900 Newton. तो इसका combined weight कितना दिया है? 900 Newton. Are you with me?
Yes, sir.
How much is alpha? Alpha is equal to 30 degree. How much is beta? Beta is equal to 10 degree. ये दिया है. Are you with me?
Yes, sir.
Just a minute, I need to take this call. Just give me a second. Hello? हाँ बोल. हाँ पण एक्झाम सेक्शन शेड्यूल करते ना. मग एंड टर्मचा पेपर येतो, मिड टर्मचा कुठे आहे? हो, मला एक काम करा, मॅडमना जयेश जोगळेकरांशी बोलून घ्यायला सांगा. हा, आणि मग असेल तर मला फोन करा, मी सांगतो तुम्हाला कसं शेड्यूल करायचं. ओके. हॅलो मधुरा.
Yes, sir.
Yeah, so this is 900. Determine the tension in support cable ACB and traction in cable CD. So we have to decide the tension in support cable ABC and traction in CD. Are you with me?
Yes, sir.
चलो, so let us draw the free body diagram. किसका free body diagram बनाएंगे? Now we will draw the free body diagram of this pulley.
Pulley.
Why? Because we have to find out tension in cable CD and tension in cable ABC. These two are external to this pulley. So if I draw the free body diagram of pulley, all these things will appear and I will be able to find out these tensions. Are you with me?
Yes, sir.
So चलो इस pulley का free body diagram बनाते हैं. So for pulley, is its self weight external? Yes, because earth is external, but its self weight is negligible in comparison with other forces, so we neglect that. Is this 900 Newton external for pulley? Yes, so that needs to be shown. Do you agree with me?
Yes, sir.
Then if I cut this cable here, I am going to see a tension in this cable, so that tension I am going to call it as TCB. Do you agree with me?
Yes, sir.
Then tension in cable AC, I am going to call it as TAC.
Yes, sir.
Are you with me? And
Yes.
similarly, I have to also find out tension in cable CD. Do you agree with me?
Yes, sir.
And CD is being parallel to AC. That tension also will be in same line. Are you with me?
Yes, sir.
So this I am going to call it as TCD. Happy?
Yes, sir.
Are you with me?
Yes, sir.
Okay. अब जरा यहाँ पे देखो कितने unknowns है. Tell me how many unknowns are there.
3 unknowns.
हाँ, and how many equations? कौन सा सिस्टम है? concurrent coplanar force system है ना, तो equations
Yes, sir.
कितने हैं?
3 force equations.
No, but there is no force in z direction.
Yeah, so 2.
2. So 2 equations, 3 unknowns. How do we go ahead? Are you with me?
Yes, sir.
हाँ, तो कैसे आप आगे जाएंगे बताओ. तो इसलिए हम क्या करेंगे? Now we will draw a free body diagram of only this much portion of the string. स्ट्रिंग का जो इतना पोर्शन है उसका फ्री बॉडी डायग्राम बनाएंगे. Are you with
Yes,
me?
sir.
Okay,
Yes.
I think we are venturing into your recess. This may not get completed today. So क्या करें? Let us stop for today and we will solve this problem in first 5 minutes tomorrow's class, and then we will take this thing ahead. Okay?
Yes, sir.
Okay. So write down your name, roll number, and then you can leave the class. If anyone has a doubt, you can ask.